CD. Alright, so hello everyone. This is I forgot which day it is. Day 8 or day 9 of unemployment. So today I'm going to solve another 5 questions. Alright. So the first question is the largest rectangular in histogram. So it gives you array, integers, height, and basically you will have to return what's the maximum rectangular area. So in this case would be is 5 times 2 is 10. So this is the largest area. We could potentially have another one is in here is 2 times 4 means 8, but it's still less than 10. So this question is like we will have to use a stack to storage its index and its current height, and we just iterate through the array. So if the stack is not empty and we compare the first the toppest one on the stack with the current height. So if it's if the current element, for example, like the first one would be 2, and then we see 1, and 1 is less than 2. So in this case, we would pop off the first one with the index and the value, and we would calculate what's the maximum area for the element that we just popped. So right now it's just 2, and then we would update our result, and also we also append this 1 to our stack. And now we go to see another one. It's 5. 5 is larger than 1, so we pop the we won't pop, we will append this 5 to the stack. And also one thing is like when we append this 1, we want our starting index from 0 instead of 1, because here you can potentially see there's a like this rectangular from index 0 is valid, so it should start from the 0. And next we go to see the 5. 5 is larger than 1, so we keep append it to the stack. And also next is 6, we append it to the stack. And now we see 2. 2 is less than 6, so we are going to pop from the 6 from the stack, and we calculate what's the current area, so which is just 6. Is 6 larger than the next area 2? Yes, it is. So update our result to 6, and we pop this out. Then we go check what's the next on the stack. It's 5. Is 5 larger than 2? Yes, it is. So we're going to pop this one, and we are going to calculate what's the current maximum of the area, so which is 5 times 2, so which is 10, so which is the largest. We'll update the result, and then we go check 1. Is 1 larger than the 2? No, it's not, so we don't have to pop it. So then we storage the 5 index in here, and we append the 2 to our stack, so we will have index 2 with value 2 on the stack now. And last one would be the value 3, and 3 is larger than 2, so we don't have to pop, we just append it. Then after we append after we finish the scheme, all the remaining elements from the stack that can be calculated their area just forward. So for example, for this 1, since it starts from the 0, so the area would be just 1 times 1, 2, 3, 4, 5 times 6. So then we remove this element from the stack. Then the next one is 2 starting from this this number 5. Then it's 1 2 3 4, so its total will be 8. And then the last one is 3 just times 1, so which is 3, and we will finish our scan. So yeah, it's kind of tricky. So we would initialize a stack first, and area is equal to 0, and we just for the current index, we just run the for loop, current value, in height. We'll have to enumerate it. So we would have a start index. Since we are going to save, if we are going to pop, we want to save the current. We want to get the start value. So while stack and current is, so if it's less than the current, if the current value is less than the last element on the stack, so stack S1. So for the stack, we are going to store as index value. So it's the last one and the second one, right? So then we would have index height stick up. So if we found a smaller element, we compare those two and we pop the last element from the stack. So then we would have to calculate what's the current maximum value. So the current maximum value is X area, and since we are going to remove it, so it would be the height times current index minus index. And I have to put a bracket here. And after that, we are going to save our save our index into our start. So remember, like for example for this one, if we want to save this one to the stack, we need to save from the beginning, because here is potential. We would have a rectangular here. So after all this, we can just stack pen. Then we would have the start and current value. So yeah, so that's why we need a start, and we need to have a current index. So if it's not less than, if the current value is not less than the last element from the stack, we just append it to the stack. And after all this, we can just check all the remaining items from the list. So for I in the stack, maybe we can use so for so we just need to calculate the mix area. Or we can just for I in lane of stack, right? Then we can just pop it. And we can get the I and height from the stack. Then the area would simply become the height. Length of height times pitch right? And we need to minus I, right? And then we just return next area. Yeah, I hope it's working. Okay, of course. Maybe I should use index. So index, and then just this. No length. No heights. Okay. So let's submit it. Okay. So this is the first question. This is hard. The next is binary search. So it gives you a sorted array and asks you to return the index of the target, and if not, just return -1, and it asks you to run in the login time. So we would initialize. So usually for this login, this means usually it involves the binary search, and this template will happens quite a lot. It's basically like a template. So we would do a while loop. So if last is less than r. So what the binary search is, you start from the left and right, then you have 2 pointers, and you just calculate what's the middle of the index. Like for example, you can maybe get this 3, and then this is the mid index, and you compare this with the target. If it's less than target, you know the target is on the right side, and if it's less than the target, means like the target is if it's larger, if it's less, that means like this number is on the left from the target, so you should move the left pointer to the right. So basically you just keep cutting in half, so that's why it's called binary search. And you just here is how I usually do it, because they can be equal, and the midpoint would be the left plus right divided by 2, so it guarantees to give you the integer. And now we have to compare this number. So if this number is greater than the target, so if this one is greater than the target, which means the target is on the left side, so we need to move our right pointer equals to m-1, else if m is less than the target, the left pointer would be m+1, and else means we find the answer, so we could just return what's the current index, and if none of these could find, we just return -1. So that's the standard binary search template. Okay. Is out of range. Should I do -1? There you go. So a right pointer should be always length -1. So yep. And the next question is solve a 2D matrix. So this question basically is also a binary search, but it's like a matrix. So we would do binary search for 2 times for this question. We will check if the number is in which row, and after we determine which row, then we determine in which column. So we would have a top and the bottom, and so to know which row it is, then we would have a left and right, and we're just doing the binary search to check if the element is in the matrix. So yeah, so top would equal to 0, bottom would be length of the matrix, and the left would be 0, right would be not top, I think it's rows and columns, right? So matrix. So after we initialize this, we can just do a while loop. So if top is less than equals to bottom, right? And we can just calculate the mid value is top plus bottom divided by 2, and then we need to calculate if matrix for me so we want to check if the first element, if it's larger than the target. If it is larger than the target, like if the target is 5, then we want to shift our button to the top, so be -1, and else if matrix of the last one. So they say if the 20 right now, if the target is 34 for this sample, so means like we are going to move our top to the bottom, so +1 like this, and else we will just break, right? So so right now I think we have we might have found the where should be the place to search, but there also a scenario is probably we don't even found the solution. So if top is greater than the bottom, then we would just return false in this case. While left is less than equals to right, the mid would be left plus right divided by 2, and if matrix mid of n is greater than the target, means like this one is larger than the target, so it means we have to search from the left, so right. Right. And if all this we couldn't find, we just return false. Man, tricks. Not sure if I did something wrong. So I think if top is larger than Alright, so it passed. Okay. Next one is Koko eating bananas. And this question, is basically you have to determine a minimum speed to eat all the piles of the bananas, and there is also a time limit. So they say if we set the k equals to 1, means it takes 1 hour to eat a banana. So from the first pile it takes 3 hours, and for the second one it takes 6 hours, 7 hours, 11 hours, and it adds up, it's larger than the edge, so it doesn't satisfy. And however, we could use like the max speed is like 11. So even it's 11, if it's a pile, it takes up to one. It still takes up to one. Still takes 1 hour to finish the pile. So in this case, it will take 1 hour for the first one, 1 hour, 1 hour, and 1 hour. So total of hour will be 4 hours. But apparently, this speed is not like the minimum speed. So we might need to check from the slowest speed, which is 1, to the maximum speed, which is 11. We will use binary search to see if there's a minimum of the speed that can finish all the piles, which gives us less than the time limit, which equals to 8 equals to 8. So so initially we will probably say k is equals to max of piles, right? And maybe we can code it m, or I don't know, like max k or something. And the left pointer will be 0, or we can call it right, because we are going to run the binary search on the speed array. So while left is less than equals to r, we would get the k, which is the in the middle of the minimum speed, which is L plus r divided by 2. And so if so, and just for I, or for p in piles, we would have to calculate the time. So we also need to have maximum time, or what's the minimum time. So do we call just time? Time is equal to I don't know, to 0. Okay. So if time is less than h, going to take the integer and the float, please. But actually it's not like we have to use the math.ceiling because if we couldn't like for example like if it's 11 divided by 4 which equals to 2 point something, then we still round up to 3, so we have to add it to the time. And if the total time is less than h, that means this is valid, so we would have a result. Maybe we could set to h maybe. So another time should be k, right? Because we want to get what's the minimum of k. So yeah. And so if it's satisfied, we would move our right pointer to the left, so it would be -1 in this case. If this satisfy, and else means it didn't satisfy, means we need to speed up a little bit. So we would move our pointer by 1 like this, and I don't know if I miss anything. I think it should be it. And we need to return the result. Start from 1 because the speed is 1. No? Where did I do wrong? Yeah, I think this one should be R because the R is the maximum speed you should get. So, for example, 11 bananas, the maximum speed should be 11 because even if you have greater speed, it still take 1 hour to finish each pile. So, the max should be K instead of H in this case. Alright, and the next question is the find minimum in rotated sorted array. So, so this question, I think the concept is you will have to check if numbers of men is larger than numbers of L. And if it is, we would move our pointer. We would so for example, so if this mid is larger than the left, means like the smallest would probably be will be on the right side. So we would move our left pointer to the right. So now this becomes the left and right. So as long as we saw the left pointer is smaller than the right pointer, that means we get our array sorted. And if it's like sorted, if we do the binary search, and if we found the left is equals less than the right, means it's sorted, then we just return the leftist of the element. So basically we would do let's say result is probably equals to let's say set a maximum number. So we can probably do like maybe not float, just 5,000 in this case. So we can also initialize our left pointer, right pointer 0, and this is the length of nums, right? So as we did before, just while the left is less than equal to right, and we calculate the mid value, which equals to left plus right divided by 2, and the result and also we need to have a finish loop scenario, which is, so if nums of left is less than or equals to nums of right, means if this array is already being sorted, because it's like sorted array, there's no way if the left is less than right, means it's sorted, since we're doing the binary search. So the right would not be the 2 in this case. So after we do this binary search, like this mid, and we will search on the right, and when we check this and we find this, and this is less than the right, so we would return this one. So -1, and I think, yeah, so in here we need to do minimum of grass and nums left. And if we found it, we just break the loop. And if not, we would search the binary search, and so like this. Okay. So I think the thing to remember is this condition, since it's sorted, so if it's rotated sorted array, so if the left is less than right, that means it's already the smallest. So that way it's possible because we are keep shrinking, the window size. And if they say if this is like the window size, maybe this is the left, this is the right, so see, the left would not be less than 2. Or we could have yeah, so there, so since it's like incremental, so there will always be so the left pointer would always reach to the 0 in this case. So even for this one, like 11 and 7, since it's rotated 4 times, so the left is less than the 17, so it returns the 11 in this case. Okay, so let's submit it. Oh. Where did I do wrong? How is this possible? Still wrong. Okay, maybe not 500. Maybe we should use the numbers of 0. Still wrong. Oh, I think in here we forgot to update our result, because we also need to check every time if we found a minimum. So in here we also need to update. Okay, so that's today's 5 questions. Hope you also learned something from my submission. I think it's hard. To be honest, I don't know if I can do this. It's making me wonder, maybe I don't, I'm not good at coding. But it's really a struggle, and I want to prove myself. And I don't know if it's meaningful or whatever. I just want to try. So wish me good luck, and hope to see you. Wait, I should probably see myself on YouTube, right? Right. Okay. Guess just me. Alright. See you guys.